So movement in space, which is on page 4 through 13 of topic 1, Earth, Sun, Moon, in our new textbooks. All right, we're going to start by doing the connect it. So first we need to circle all the meteors in the photo. Why do meteors leave a trail of light as they move through the sky? So here we have the meteors in these 2 locations that I've circled. Please circle those in your textbooks as well. Now, why do you think meteors leave a trail of light as they move through the sky? And that is because the light is emitted when the piece of rock, dust, or ice burns up as it enters Earth's atmosphere. Aryabhata I was an early astronomer who asked questions like, why do the stars appear to move? What makes the moon shine through the darkness? He answered his question, the moon and the stars shine because they reflect light from the sun. He made these observations with his naked eye. Recall a time you observed the sky at night. Which objects were you able to see? Check all that apply. Stars, the moon, airplanes, comets, planets, the sun. So obviously you can't check these things, but what I want you to do is get a Post-it note and write your name on it and write all of the things that you've seen, either A, B, C, D, E, or F. So either one of those, all of those, just one instance. Stars, planets, and the moon. Earth's moon is the brightest and largest object in our night sky. The moon is a natural satellite of Earth. A satellite is a body that orbits a planet. Stars in the night sky look like tiny points of light, but a star is a giant ball of superheated gas or plasma composed of hydrogen and helium. A planet is an object that orbits the sun. It is large enough to have become rounded by its own gravity and has cleared the area of its orbit of any debris. There's a video link here, and I will post that in the topic with the title. So in Google. Meteors and comets. Meteors are a streak of light produced when a small piece of rock or ice, known as a meteoroid, burns up as it enters Earth's atmosphere. A comet, which are rarer than meteors, are a cold mixture of dust and ice that develops a long trail of light as it approaches the sun. An example is Halley's Comet, which appears about every 75 years and last appeared in 1986. So Halley's Comet, math toolbox. In 1910, Halley's Comet traveled close to Earth, about 1/7 of the distance from Earth to the Sun. Earth's distance from the Sun is 149.6 million kilometers. So 1, create an equation. How close was Halley's Comet to Earth in 1910? Create an equation to answer the question. So here we would do 1/7 times 149,600. Sorry, let's try that again. 149,600,000 kilometers. And that is 1/7 of Earth's distance from the Sun, which is equal to 21,370,000 kilometers. Then for estimate the next 3 years when Halley's Comet will appear. So if we take 1986 plus 75, we get 2061. 2061 plus 75 is 2136. And 2136 plus 75 is 2211. The core of Halley's Comet is oblong in shape, with its longest dimension 16 kilometers long. Earth's diameter is about 12,700 kilometers. How many times larger in diameter is Earth than Halley's Comet? And if Earth's diameter is 12,700, you'd make an equation that's 12,700 equals 16x. Divide both sides by 16, so 12,700 kilometers for Earth's diameter divided by the 16 kilometers that is Halley's Comet, and you get about 794. So it would be about 794 times larger. Star charts can help you find constellations in the night sky. This is a summer chart for the Northern Hemisphere. Find these constellations in the star chart, then write each constellation's name by its picture. So here at the top we have Ursa Major, Scorpius is next, and Leo is last. And our reading check. How do the pictures in Figure 2 help you remember the constellations? Each picture helps me see which stars belong in a group. The pictures help me remember the names of the different constellations. Your answer doesn't have to be exactly that, but should be something similar. Constellations. So what is a constellation? It's a pattern or group of stars that people imagine represents a figure, animal, or object. Today, scientists divide the sky into 88 constellations. Some are named for people or animals from Greek mythology. Movement in the sky. Stars, planets, and other objects appear to move over time, but really just depend on the motion of Earth. Stars appear to move from east to west and take circular paths around the poles. The sun's apparent motion is caused by Earth's rotation. So here's an image of Figure 3, star trails. So a time-lapse photo taken over the course of minutes or hours captures the movements of stars. The North Star happens to be aligned with the axis of Earth directly above the North Pole. Circle the North Star in the photo. So this is Figure 3 in your textbook, and you are going to circle the center point of the stars here that everything is rotating around, because that's your pole where things are rotating. Here we have a YouTube video, which again I'm going to link in Google Classroom with the title. Seasonal changes. So constellations visible to us vary from season to season. Orion in the winter is moved to the west by spring and disappears shortly after sunset. These seasonal changes are caused by Earth's revolution or orbit around the sun. Each night, the position of stars shifts slightly to the west. Constellations that used to appear in the sky eventually move behind the sun, where the sun's bright light blocked them from our vision during the day. Again, here's another video. I will post it in Google Classroom. Planets. Planet comes from the Greek word meaning the wanderer, because the planets all orbit the sun in the same plane. They appear to move through a narrow band in the sky. This band is called the zodiac. Some planets are visible all night long. Mars, Jupiter, and Saturn are all farther from the sun than Earth is. When Earth passes between them and the sun, these three planets are visible after sunset. Venus and Mercury are only visible in the evening or morning. Since they are closer to the sun, they appear close to the sun. So our reading check. Why would you need two different star charts for finding constellations in the summer and the winter? Answer. The constellations you can see vary from season to season. These seasonal changes are caused by Earth's revolution around the sun. In winter, you see the stars that are on one side of the sun, and then in summer, you see the stars that are on the opposite side. So the planets Mercury and Venus never appear far from the sun in the sky. Where in the image is Venus furthest from the sun? Place a dot on the image to indicate the spot. And that is going to go right here where I put this pink dot at the very point of the ellipsis of their orbit. Models of the solar system. Ancient people noticed that even though it seemed that the sun, moon, and stars seemed to move around the Earth, they stayed in the same position relative to each other. Aristotle came up with the geocentric model of our solar system. Geocentric means putting the Earth at the center of the universe, with all the planets and stars circling it. Later, Ptolemy further developed that theory to say that planets move in epicycles, or small circles, as they move along their orbital paths. This theory was widely accepted for 1,500 years after his death. The geocentric model. This geocentric model shows our solar system with Earth in the center. The other planets orbit each and move along their epicycles at the same time. All right, the heliocentric model. Aristarchus, who lived 400 years before Ptolemy, developed a heliocentric model. Heliocentric is sun-centered model of the solar system. Many people thought he was wrong, stating that of course the Earth had to be at the center of the universe. Nicholas Copernicus further developed the heliocentric model. He proposed Earth's rotation and revolution around the sun. Tycho Brahe and his assistant, Johann Kepler, were more accurate, figuring out that the orbits of the planets were not perfect circles, but an ellipse, which is an oval shape. Galileo Galilei gradually convinced those that still insisted that Earth was at the center of the universe that the heliocentric model was correct. In 1610, using a telescope that he made, he discovered moons orbiting Jupiter. These moons prove that not everything travels around Earth. All right, in your workbook, explain what each of these four scientists added to our understanding of the heliocentric model of the solar system. So, Copernicus proposed that Earth's rotation and revolution around the sun explain the observed movements of the stars and planets. Brahe and Kepler, based on Brahe's observations, Kepler determined that the orbit of each planet is an ellipse rather than a perfect circle. And Galileo discovered moons around Jupiter, which showed that not everything in the sky travels around the Earth. Confirming the heliocentric model. So Galileo later also discovered that Venus goes through phases similar to the moon's phases. But since Venus is never too far away from the sun in the sky, it would not have a full set of phases if both it and the sun circled around the Earth. Therefore, Galileo reasoned the geocentric model did not hold true. We have a brain pop here about Galileo Galilei, which I will post a link to in Google Classroom. So that finishes lesson 1, and you should go to the lesson 1 check on page 13. So before we do that, though, let's do this last reading check in the Modelet. So how does the development of the heliocentric model show how scientific ideas change over time? An early scientist, including Ptolemy, created models that showed Earth at the center of the solar system. When evidence mounted that this model was incorrect, scientists developed new models to explain planetary motion. For our Modelet, we are supposed to draw Galileo's heliocentric system and show and label evidence he produced to support his model. So your image should look something like this, with the sun at the center, the Earth in its orbit around the sun, and the moon in its orbit around Earth, and then Jupiter with its orbit around the sun, and the orbit of Jupiter's moons around Jupiter. All right, so now to the lesson check. Sorry for that brief interruption there. So 1, 2 photographers take time-lapse photos of the night sky. One of them is at the equator. The other is at the South Pole. Which photo will show stars that never rise or set? Explain. So the South Pole will show stars traveling in circles around a point overhead. The photo taken at the equator will show stars rising and setting. 2. Explain the two theories about how Earth and the Sun move in space relative to each other. Some early observers believed Earth was the center of the universe. Based on observations of the movement of stars, moon, and planets, they made geocentric or Earth-centered models. Later, scientists observed that the planets all revolve around the Sun, not Earth, so scientists made sun-centered or heliocentric models. 3. What observations made by Galileo supported Copernicus's theory about the solar system? So Galileo discovered moons orbiting Jupiter, showing that not all things travel around Earth. He also observed that Venus goes through phases, much like our moon's phases, suggesting it orbits the sun. Galileo also found moons that circled another planet, Jupiter. So which patterns in space are predictable? Why? So the movements of planets and moons are predictable. The patterns of stars are also predictable. The position of objects in the sky depends on the motions of Earth. Last question, number 5. What causes the stars to appear to move across the night sky? And Earth's rotation around the sun causes this. And that ends lesson 1. Thank you so much.